All right. Hey, friends. We've started the recording for I think, US time slot for
Yep.
the Flux Dev Meeting, and this is December 11th. Stefan, did you want to kind of lead us on some agenda topics? No, we'd also talked a little bit about Silva and Captain as well.
Yes, we can talk a little bit about Flux 2.7, where we at. We released a bunch of patches after the first stable release. Then, I don't know, maybe we can ask Renato what he's bringing to the meeting. Renato, do you want to discuss anything specific?
Hey, thanks for having me. Yeah, I just started working in Flux and I'm really excited about the project and I want to contribute more. I have a couple PRs open in one in Flagger, one in Source Watcher. And yeah, I wanted to see if there's anything I can do to help.
Cool. Yeah, great. Let's talk about Source Watcher and Flagger, your contributions.
Okay, let's see. So this is the PR for Flagger. It basically adds support for session stickiness for the primary deployment in Istio. That is currently only supported in Gateway API. So it basically just did the same implementation, but for Istio APIs.
All right, I've seen that. My question is, um, why are people still using the Istio API? I would really like to be. I hope like Istio adopted Gateway API. I think it was the first ever project. Gateway API is quite inspired by Istio. But I've seen, including this year, asking for features in the Istio API and specifically for the Istio API. Are you using Istio at your job? It's can't switch to the Gateway API. Are there any blockers there? I'm not fully aware of what's happening with the Istio project right now.
I don't think there are any like technical blockers. It's just a matter of um, being able to migrate all of our services and all the Helm charts because basically today in my company where I work, um, each service gets its own Helm chart. So we would need to update basically all the Helm charts, which is, uh,
Oh.
yeah.
But how is that working with Flagger? Because the Flagger canary basically generates all the Istio objects, right? So if you have them in your Helm chart, then you all basically mess with Flagger big time.
Yeah. Flagger is, there are less people that use it, so it's a bit easier to get people changing a few things here and there. They're actually asking about these things, so they're much more interested. Uh, so it wouldn't be like I'm going to a completely random service owner and like, hey, change your Helm chart, and it's like, no, I got a 10 weeks of stuff to do
Cool,
first.
cool, cool. But okay, so in the Helm chart, do you have a Flagger canary definition?
Yeah.
Or okay, cool. And I'm guessing the problem is that you have the Istio gateway, right, on all clusters. So you need to
Mm-hmm.
orchestrate something like switching to gateway from gateway API without removing the Istio gateway, and then gradually switch the Flagger canaries to target the gateway API, all the other charts replacing virtual service, virtual routes with HTTP routes.
Yeah.
Yeah, it's a lot of work.
Yeah, it's not like there are no technical constraints. It's just like a lot of things to do.
Are you also using Flux for deploying the Helm charts? You are having Helm releases, I'm guessing, right?
We use Flux for platform stuff. So I'm a platform engineer where I work. So for like, we're just recently migrated Prometheus to use Helm releases. We have been using Pulumi before, and we do want to use Flux for developer Helm releases. We're just not there yet.
Well, yeah, I'm wondering if some magical admission control could ease that transition where, let's say, you have something that watches for virtual services and virtual routes and translates them to HTTP routes.
Mm-hmm. Yeah, we did do a little bit of that with Kyverno, right? So
Mm,
basically, we had a problem where we needed to change gateways, and currently in the Istio API and in the Gateway API, you have you reference the gateways by name,
right.
and we needed to change the name. And again, we have a bunch of Helm charts spread across the company, so we created Kyverno policies to actually change the name of the gateway in admission to bind to the new one. Um,
Right. Also, the Flagger canary has the same issue, right? And that's because of Flagger has to adapt to the design of the gateway APIs. So you
mm-hmm,
reference an Istio gateway by name, and also with gateway API, you have the same issue. But now I've seen, so if you look at the latest gateway API, no, the previous one, not the latest gateway API release, the previous one that we also updated in Flagger. Now they have this setting where you can, from all your gateways, you can say this is the default, and you set the default in the gateway.
yeah, I was
Uh,
looking at that. I didn't understand if it was the gateway or the gateway route, but it's the gateway then.
I think it's the gateway. Yeah. So then you don't have to hard code the gateways in your routes if you don't specify them. It should pick the default.
Right.
But this will not work in Flagger because Flagger, uh, when you set a canary to the gateway API, we require the gateway name there. So I think this is
Mm-hmm.
something to look at next year for Flagger. If you can look into this, I think it will be a great use case to make the gateway optional in Flagger. So then this kind of change that you guys are making, and it's such a pain that you have to mutate everything and so on, then let's say for when you switch from Istio to Gateway API at some point, you no longer have to hard code the gateway anywhere, not in the canary, not in other objects that are not controlled by Flagger, but are, you have some HTTP routes and so on. I think that will definitely make the whole thing more maintainable for the future. I know for sure we require now a gateway specification there because, well, this is kind of new, the default one.
Mm-hmm.
But if you can look into this, I think it will be a good contribution. And it's not, I don't think there is much to change. It's just not validate the gateway. If a
Mm-hmm.
gateway is not set, don't try to set it in the HTTP route, and then the default should take over, right? So I think the changes are minimal, but they kind of solve this issue that you are having, and you're not the only one. I've seen that in the gateway API discussion that a bunch of people saying like, can we have label selectors? Can we have something else? We don't want to hard code the names. And the solution was having a gateway as default. So basically, you no longer specify it, which is better than hard coding the name or hard coding a label in the end. What happens if you change the labels, right? If you are in the same uh, in the same spot. Okay,
right?
for the Istio with session affinity for primary, did you manage to write end-to-end tests for this?
Yes, I basically
Mm.
uh, copied or was inspired by the gateway API tests. So they are very similar. I think it's at
Yes.
the bottom.
Oh, yeah. Istio test session affinity.
Hmm.
Cool. Let me kick off the end-to-end and see if this passes. Oh, end-to-end did pass. Let's see. Man, this is still stuff. So now it takes 20 minutes to run the intent test, and we are using the most powerful VM from GitHub Enterprise.
Hmm.
Running a test suite costs, I don't know, hundreds of bucks for every PR.
That's why they don't run automatically, or they do run automatically?
So there is a protection in GitHub against forks from unknown people.
Oh.
Got a bunch of people got hacked because of that or lost a bunch of money. Like a bot can open 1,000 pull requests in Flagger and that will generate, I don't know, $1 million dollars in
Hmm.
cost. So if you contribute for the first time, they will not run by default. Someone from a maintainer has to approve them. But because you contributed before and I merged something that you contributed, um, then you are like trusted even if you open from a fork. So that's why the end-to-end tests have run on your pull request.
Okay, that's good to know.
Cool. So everything looks like the test did what it's supposed to do. Cool. So what I will ask is, did you edit docs for this? I think it's the only thing missing, right? Mm. So we have, if we go to docs flagger.app, we have Istio progressive delivery tutorial, and we have here a section about session affinity. So if you go to tutorials, the second one, Istio canary deployments. Then if you scroll down a little, yes, session affinity. So I think in here it will be good to add the docs. Wait, did he drop?
Hmm. I think
Yeah, he dropped.
yeah, he had to drop. Okay. Well,
Maybe
we
his
could
connection is. Yeah, I'll comment on the poll first.
comments on the PR. Yeah.
Yeah.
Cool. That was 1861 flaggerpole.
Yeah, I found.
Okay, I'll leave some notes. Okay, there's that. Looks like Ronaldo is jumping back on with us here. And
Hey,
yeah,
sorry, my got a blip here. I'm back.
no worries.
Okay, so what I was saying, I also commented on the pull request. So we really need to add this feature to the docs under the session affinity section. And explain how people can use it. You can take some inspiration from the gateway tutorial, but we definitely need like let people know, right? If we implement something, we need to document it. Like no one will know there is this capability without it. And we have a session affinity section. That's the right place to add it there as a.
Yeah, 100%. I did.
Yeah, I've seen you mention it. Also, this is also supported for Istio, but in the
Hmm.
overall docs around supported strategies. But we really need to have it here.
Oh,
A
right.
phrase
On the
phrase or two with a small example what you need to put in your canary definition to have stickiness for the primary, which yeah, it was we can't enable this by default because for some apps don't actually work, doesn't actually work, but yeah, it's something that people should be aware. They should be come here, they read it, they copy paste the small
Mhm.
snippet of YAML to add it to their own canaries. Or if you build a canary from scratch, you should understand how to do it.
Yeah, I agree. Makes sense. I'll add it some I'll add some comments to the documentation.
Cool. Yes, and with this, with all the end-to-end tests, I think we are fine to merge it. I plan to do a Flagger release in January, and if we merge it this month, it will go on there. Let's go to the other one, the source watcher.
Yeah, this one we actually talked about in KubeCon. I don't know if you remember, but it's a very simple implementation, basically adding Helm chart as a source in the artifact generator. It's a very simple PR, is basically because adding types. We can take a look later.
Mhm.
Let me get the link here. I don't know if I shared. Oh, there it is. Okay.
Okay, you had the watcher, same predicate. Yeah, I don't think we need more than this. Yeah, so what you should be doing is rebasing because this can't be merged, and
Mm, okay.
I'm going to approve it now. When you rebase it, I'll merge this. Is all good, thank you.
Sounds good. Thank you.
Yeah, there is one more thing here to do in Source Watcher around external artifact as a source. Yeah, but we need to write more things here. The problem is the thing is that so with the external artifact, you can have some other third-party source controller, which is not actually Flux. And you can't use artifact generator for any of this, right? Because source watcher is only watching source controller APIs, but and it produces external artifacts, but it can't consume external artifacts. Um, so I think the challenge here is with the watcher because we also produce and now we want to consume. I'm not sure if this will be very noisy for the controller itself. Like when it generates an external artifact, they need to receive. But on the other hand, you also can't say, oh, you are not supposed to do anything. You can't do any more transformations for artifacts generated with source watcher. Maybe, I don't know, maybe there is this use case where you have a source, an artifact generator. It produces some artifacts from some sources. Then you want to use those chained in another artifact generator that does other stuff. Uh, and at first look at it when I talked to Mateus long time ago about this. So I can this doesn't make sense. Why wouldn't you put all the copy operations in the original artifact generator? But what if you have so many operations and it gets a single artifact generator gets so complex that it's very hard to understand and manage, and you want to split it in like a workflow where first you perform some operations. I don't know, you generate Helm charts from Git repos. Then you have another artifact generator that takes those external artifacts, which are the charts, and uses another repo to swap values or merge values and so on, right? So maybe it would make sense in the Helm context where you don't want to couple the extraction of Helm charts from some monorepo with um, fine-tuning those charts, personalizing the values of those charts for a particular tenant or in another namespace. So thinking more about this use case, I think we should definitely allow Source Watcher to watch external artifacts and be able to consume them because yeah, it's
I think there's right now there's no other producers of external artifacts than Artifact Generator, but I think the primary use case for consuming external artifact long term in the ecosystem would be to be able to use Artifact Generator on the products of things from third-party controllers.
yeah,
Like,
that's undebatable. I'm not debating that. Like that's how I studied. Like of course, for third-party source controller makes a lot of sense.
mhm.
I was debating if should we limit the watcher and eliminate the external artifacts which are labeled by source watcher because we have particular labels. We know that an external artifact is actually managed and produced by source watcher. So when the discussion was around, yeah, of course, like there is a third-party source controller already out there. People are using it, made by Config Hub, right? So
Mhm.
just because there is such a third-party source controller, we should definitely add external artifact here. The debate was, should we exclude the ones that Source Watcher generates or not? And um,
I
at
see.
first I said like, yeah, maybe we should exclude it, makes no sense. Then thinking about this Helm chart, extraction from a monorepo, then transformation of the values YAML, maybe in a tenant namespace, maybe we shouldn't, deny source controller to consume its own external artifacts because there are different artifact generator objects that may have different roles.
Yeah, I
Um,
think the cross-tenant usage of sources with cross namespace ref, and then the fact that the tenants would own different transformations from different API objects that could be controlled by different RBAC would be a really key feature there of the API. Um, but so then the question would be, well, would you then limit it within a namespace? But then even within a namespace, people can still limit RBAC for specific resource names, and you can do things like hierarchical namespaces, even though that's a deprecated project now. Um, and I think the main edge case here that comes to my mind that would be dangerous to the controller's reconcile loop that we should have some consideration for, maybe a rate limiting thing on like a token bucket by the uh yeah, on like a token bucket on the name of the source would be to guard the control loop against um the reconcile being like getting an event storm from a loop, like a cycle, because you can create a
No, I can definitely see how you can go into a infinite thing, right? You
yeah,
have like
I think you can
two
just rate
artifact generators, they consume each other's artifact, and then the controller will always
because
be like,
if it was not firing off of notification controller, then that would be well behaved at least in that it would just cycle on whatever the interval is, right? And the intervals are usually relatively long to like we're doing some file system operations. Maybe somebody wants to create a clock um with their sources using artifact generator transformations, which would be really nuts, but sure. Um like you could create a clock or a sequencing thing or whatever. Um, but that feels like it would be a really unintended, like for the most part, it would be an unintended configuration and a mistake. And you could just catch it with and produce warnings with like by rate limiting the transformations or something on a particular source from some reason. That could be one way of doing that. You could also do a cycle detection and then just say, no, this is not allowed. What do we do for depends on?
when we build it, we build a tree and we error out.
Okay, yeah. So if there's cycles, but it only errors out for the reconcile of that particular thing, right?
Yeah.
So it doesn't affect the reconciliation of other things. But what wins? Like when there's a cycle between two things, can can a cross namespace dependency stop the reconciliation of something else?
I haven't read that code in years. I need to look
Yeah,
at it again, but I'm not
it's a
sure.
good question. But
Anyway, it's
we would probably do the
documented
same
to
thing.
not create chain loops. That's for sure. And people
Yeah.
got there, and they got the spam or customized controller notifications, events, um, and they stopped it. So
Yeah. Also, this cycle can actually happen in between controllers, is not the case. Like,
between controllers, no, because we don't have Helm release cannot depend on a customization and vice versa.
no, but what about between external artifacts? Is it possible to create a cycle by, like, say there's like a config generation controller, like Q or YTT, then if the controller produces an artifact that causes, I see. So the controller would have to be watching its the external artifact that artifact generator produces. The reason why this is a problem in an artifact generator is because the output of artifact generator can also be the input of
Yep.
artifact generator. So it's really more so if another controller does that same thing. Like if another controller can accept an external artifact as an input, which is potentially reasonable if it was like a transform controller, right? Like that's what artifact generator is. It's like a transformation thing. So if you have something that could take like any Flux source, like a Git repo or a OCI repo or an external artifact, and then perform a config transformation on it and then produce another external artifact, then you could get the same looping behavior that we're concerned about happening inside.
Yeah, and there is no way to defend against this
Yes, because that would be a product of an API that
of
you don't
something else.
control.
Yeah, and you
Yeah.
can't just reject.
No.
Anyway, um, we plan next year to adopt priority queues from control runtime, and
Mm,
priority
actually,
queues will
Stefan,
solve some of the issues.
let's
Like,
revisit that. I actually we asserted that there's no way to defend against it, but I think actually the rate limiting suggestion would defend the cross controller cycle. It would mitigate it. Like you would be able to decide and provide tuning flags to just so that the cluster operator would be able to own what happens there.
yeah, I mean, adopting priority queues will kind of solve some of these issues because if you can prioritize something by
Yeah, by the you can
you
deprioritize.
can do a
Yeah.
debounce basically. You can debounce something that keeps reconciling all the time and move it to a low priority queue so you
Mhm.
can do work for other things that matter in the cluster. So
I would expect that if Flux adopts priority queue, we would need to consider exposing it as a feature flag. And B, potentially be willing to work with the Googlers and the folks in controller runtime that wrote the priority queue, because I do recall when we were doing some benchmarking and performance tuning on a large cluster that um, we identified that the priority queue implementation in controller runtime can have a starvation issue, which is currently not possible right now. Like the original, like the current controller runtime queue is quite fair because it's pretty first in first out. Whereas like you definitely right now from the discussions and the implementation, there's nothing that prevents starvation through like aging or like any kind of uh like time measurement or quantity measurement mechanism for things that just stay in the queue for so long. So like you could get things that just like never reconcile. And maybe that's what people want in a priority queue, or maybe it's not. Feels like a reliability or issue, or potentially even an availability issue. Like say if the um like a root external artifact, like a something very high up in the tree that is like the entry point for somebody's core Git repository, ends up being starved from the priority queue, then you would never be able to change the controller behavior. And then maybe the reconciliation's like running away. So we should really look at um or at least have an explicit opinion about starvation with the priority queue implementation. And it might require some contribution from us, or at least to call it out in the docs that it's a possibility and feature flag it.
yeah, I mean, by default, the priority queue solves the issue of restarting a controller. That's its only the only thing it can do in control runtime right now. Um,
Solves the issue of,
the-
sorry, what?
you know what happens when you restart the controller, right? When let's say you upgrade the controller or the node where it is, the pod gets lost. When a controller starts, it needs to reconcile everything,
Yes.
right?
Mhm.
And the only goal of the priority queue as it is today in control runtime is to solve this issue where things that haven't changed based on generation and other stuff will get by default a lower priority than the things that actually change while the controller was down, which is you always want to do that.
Hmm.
So let's say you are running a Flux upgrade, customized controller is restarting. Maybe you need to download the image, maybe your egress is not that good, and it
Yeah.
takes, let's say, 2 minutes. And in that 2 minutes period, someone does a git push. You have 10,000 customizations on your cluster. And when customized controller restarts, it should prioritize reconciling first the things that have a drift in the generation, the things that have been modified while it was down, not reconcile and do a dry run for everything and randomly get to the thing that was actually changed, right? And this is valid for any other controller out there. Then so this adopting the priority queue now it's enabled by default in the latest version of control runtime. We haven't switched to that. I don't think we should ever feature flag this stuff. Like this kind of
Mhm.
behavior is everything that every controller wants this.
I think we should be careful about that because like since Flux reconciliations can take a long time, if there's a high enough volume of change in the cluster on, say, customizations or Helm releases that take a long time, then you can get to a point where starvation with this priority queue implementation is a serious problem.
How is
Um,
it different from the default? Like the default, you
Very
get
different.
everything randomly.
No, it's very different. If you this priority queue implementation, if it's prioritizing things that are changed, and the quantity of reconciliation time, the duration of the reconciliation time is longer than your controller's concurrency allows for, then all of the higher priority items will be the only thing that's ever reconciling, and you will never get to the lower priority stuff.
But the
Which
lower priority stuff are useless. You shouldn't be reconciling those at all because it haven't
you
drifted.
absolutely need to reconcile it because the
Why?
promise of Flux is so that configuration drift doesn't occur.
No, this is like a total bug in Flux. Flux shouldn't reconcile anything when it restarts because Flux is not made to
This
do
is
that.
not just for restarts.
No, this is just for restart. So when the controller restarts, it receives all the things in the cache. So the cache is fresh
Uh-huh.
and the cache gets filled with 10K customizations.
Hmm.
Like we never intended for Flux at the restart to do 10K dry runs because Flux isn't supposed to do that. Flux is supposed to do a dry run at the interval, like killing the pod and reconciling the whole cluster state is a huge problem in Flux because people don't want to do that. Like there are so many Flux users over the years saying, hey, I've set reconciliation at 2 hours. I've restarted the pod after 1 minute and that stuff reconciled. Why? Well, because this is how control runtime works, right?
Yeah, because now when the queue has 10,000 things in it, then if something changes, like the stuff that's at start is a lower than default priority just by how it got loaded into the queue. But the the problem with that though is during runtime, if anything is submitted to the queue with a different priority, you can end up with the starvation issue that I'm talking about. Exactly. Like if there's anything that can
No,
happen
it shouldn't.
during
It shouldn't
runtime
be.
that changes the priority of it. Like say if you were like prioritizing things with a recent change versus things that are not at runtime, like then things that are changing could starve drift correction on the cluster
But
completely.
we have control of that because no, that's not the case. We can actually decide this because we reschedule things.
Yes, yeah, we decide what the priority of things are.
Of course. And we are going to set the same priority as if something else changed.
Yeah,
So they'll have the same
that's what
priority.
I'm getting at though, is that like this is a serious risk to Flux, this priority queue implementation. If it's used incorrectly, it's a big foot gun. And
Yeah,
we
yeah.
need to we have to have a very clear stance on it and accept the risk of the feature being in the project. And if it gets misused by our code, like we can cause significant reconciliation issues in clusters that are where the performance limits are being pushed. Um, and
If you
if we want to
reschedule with
use
the
this,
same priority, I don't see any issue here. Like,
yeah,
why would it
well,
be?
the reason we were looking at the priority queue feature in the first place was to be able to issue errors at a lower priority than everything else. And one of the reasons we ruled it out is because it, like, right now, it would take a lot of effort to have a queue implementation or improve the queue implementation or fork it or not fork it, but extend it, implement it um, in a way where there would be a starvation
Oh
mitigation.
yeah, yeah, yeah. I'm not saying that
Because,
we should mess with the priorities in any way. What I'm
yeah.
saying is that we should definitely upgrade to control runtime,
Hmm.
get the benefit of on a restart, reconcile the stuff that we actually care about and not
Hmm.
all the things that no one cares about. And that's a huge problem in Flux with restarting. And that will half solve the issue. We are still going to reconcile everything, but before doing useless dry runs, we are going to do the actual work. But then when we schedule things, everything that gets scheduled, no matter if it's an error or it's a normal interval, they should all schedule with the same priority. I'm not for changing, at the control runtime upgrade from changing that kind of, then coming up with different priorities for errors, different priorities for normal reconciliation, have a high priority for things that change while the control runs. Because how we do it today is it's kind of a breaking change if we do that, right? Then we need definitely flags, like you're saying, because we are like, now people know what they expect from Flux controllers. And we can't just say, oh, when the controller usually runs, now things will happen in a different order, right? That definitely needs to be feature flag. But the behavior at startup, which is the default now in controller runtime to prioritize the thing that's changed, uh, that there is no way we need a feature flag. Like everybody wants that kind of uh, behavior. This is how Flux should have always worked. Sadly, we didn't have the tools to make it work like that. But now, after we do this, maybe we should actually consider not doing any kind of dry run at all and just keep them at restart based on an interval, right? We have this kind of thing only implemented in Flux operator, where and this is not anywhere in Flux, but we can actually think of doing the same stuff. So in Flux operator, we have this scheduler concept where you can do like controlled deploy windows when you say, I only want to trigger reconciliation between, I don't know, every day, 2 hours per day in the morning, or no deploy Fridays or stuff like that. And how we've implemented that, of course, we have some cron things, but we calculate when is the next time we should reconcile as a desire. We can't guarantee we can reconcile immediately on the tick, but we actually store in the status when is the next desired reconciliation timestamp. And in Flux, we don't do that. If you set interval 5 minutes, right, we schedule after 5 minutes, but we don't store that in the status. And we don't do that because we can't ensure that stuff due to the restarts and all of that things. But if we would persist the moment when we schedule something, we will also persist the timestamp when ideally we should reconcile again. At the pod restart, we can actually check the timestamp. C is like, I shouldn't be reconciling now. The next reconciliation, the desired state is in like 1 day from now. Skip it. Don't do the dry run because dry run is extremely expensive when you do dry run of tens of thousands of things on the cluster. And this feature could be under a feature flag, right? But because even if with the priority queue, okay, we are going to reconcile first the things that actually matter to people, but we will also do all the other stuff at restart, just in a different order, right? We are still not solving the issue. You restart customize controller, you have 10K customizations. We are going to do millions of API requests to do all the dry runs. Even if they don't fall into the schedule interval that people actually expect Flux to do. And we did solve this in Flux operator, even if at restarts, Flux operator will not reconcile something. If it's not close to the range of the desired reconciliation window, then we are not going to do it. And now I'm thinking that you mentioned that, storm of dry runs, that what we did in Flux operator will be very beneficial in Flux as well. Of course, under a feature flag, but I think people that have like these gigantic clusters with tens of thousands of apps, right now for them it's very expensive to restart Flux, right? Yeah, something to create an issue for them, think about it more.
Yeah. When we did the batch reconciles with the status filters, in Flux Operator CLI, did you do that just only for Helm releases or customizations too? You can like reconcile all Helm releases now in Flux Operator CLI.
No, it's not about Flux operator CLI does not even know about Flux types.
Didn't
You
we put
can say
that you
you
can
can
reconcile?
say you can say
Oh,
trigger
okay.
a reconciliation for this kind,
For some kind. Yeah.
for some kind. And if that kind knows how to react to that annotation, it will do it. But Flux operator CLI is agnostic of Flux API.
Yeah, but we added like a status filter for it as well, right?
Yeah,
Yeah.
of course.
Yeah.
And the status filter works for any Flux CRD, doesn't matter what it is.
Yeah.
So it's not, of course, it's not just for fan releases. It can be for anything.
Yeah.
But
Uh,
it's not related to this. Has nothing to do with what we
It's
are just
mildly
talking about.
related from a UX perspective. If we implemented a feature that we like right now, the hammer for somebody, if they want everything to reconcile, is they can restart the controller. So if the behavior of the controller was changed,
Sure,
then
yeah.
yeah, like it could be useful to put it in the upstream CLI or something, or point people to Flux Operator CLI or something.
Yeah,
Um,
yeah, yeah.
Okay. Yeah, I do like the thoughts on persisting status timestamps so that the controller can precisely promise when it was supposed to reconcile. Um, that definitely load sheds at scale. Because for me, I was thinking kind of more stochastically, like what if we picked a random time and had a bigger jitter at startup that was only specific to startup or something. But yeah, the persisting in the status would be vastly superior. Um,
Also, from an observability point of view,
yeah, I mean,
like
right now, I think like what is it? It's a capacitor. Oh no, it's headlamp that I think headlamp and capacitor have like the countdown feature, and it's just a guess based off
yeah,
of
it's copied from with GitOps. That's where
yeah,
we did it.
but it's
First time, and it's crazy guess.
yeah, it's like you don't know if that's gonna happen. Like if the queue is backed up, like it could be 10 minutes from now instead of 2 minutes from now. Even and it'll just be counting down from zero forever, like um it's like, yeah, I'm supposed to get a reconcile, but it's not happening. And it's at least now with the timestamp. Um yeah, I guess if the queue is backed up and the timestamp says it's supposed to be at a particular time, it's still not going to reconcile at that time. It's not a promise.
The problem with um, this timestamp in the status is the restart. Because if you don't skip it at restart, then the timestamp is a lie. Uh,
Yeah, I
so
think, yeah, when you restart, like if a reconciliation is like issued like significantly earlier than the timestamp, I don't even know how you would tell that like I have this reconcile event and actually it seems like I'm not supposed to be doing this right now. You'd have to have some heuristic inside of the reconcile loop for that. Like if it's over a minute off or something, then you don't touch it. But if it's within a
yeah,
minute,
I mean, let's say you like a good example is you know um, image policy that scans an image policy and registry that scans Docker Hub, right? You
hmm
definitely don't want to do that every 10 minutes because you are going to be rate limited unless you pay and whatever, create tokens and so on, right? So
yeah.
what most, let's say, people that are like me that are running Flux in a home lab, I'm setting that, update, check for a new Redis version every day.
hmm
Or every 24 hours is my case. Everything that touches Docker Hub is 24 hours because I have more than one image repository looking there scanning things. So I don't want to hit that 100 requests per day limit. And it works great unless I restart or unless I upgrade Flux, where if let's say I have Flux operator and there are like, I don't know, I have the enterprise version, and if there are like three CVs in the
hmm
morning, in the afternoon, and in the evening,
Every CD patch is gonna auto update, and then all
I'm
of
gonna
these.
auto update. Another use case. Maybe I'm running to lower my costs, Flux in my AWS account, and I use those cheap nodes that you can
Bots.
purchase,
Yeah,
and they disappear all the time, right?
moving
There
flux
is no
around.
guaranteed. There
Yeah.
is no guarantee they will stay around for 24 hours, right? So that means that when image reflector controller restarts, it will scan everything in parallel. It will definitely hit all the rate limits of Docker Hub, even of other um, uh, registries, because you do so many things in parallel. Like you have like four
Uh,
in parallel. You do get of all the tags. Tags get paginated and they count every to get every page. It's a request, right?
we
So
already we already have the last reconcile time in the status.
yeah, but we don't do anything with it.
Yeah, yeah, yeah.
Uh,
What I'm saying is, technically you could you could bail out of like with information that's already in the status. Not saying that we shouldn't put the desired time in there, but it is important from from an aspect of like the old APIs as well. Like there is already enough information in the status to exit early and re-queue for later on if there is a reconcile. Like you could say the the scheduling the default scheduling accuracy of Flux's interval should be 1 minute. And if a reconcile comes in and you look at the last reconcile time and take the interval and extrapolate it, and it's fine even if the value changes. In fact, the value changing is really important here because if you have a queued reconcile time, like say you changed it from 1 hour to 5 minutes, and then like you need to be able to know this reconcile with the 5 minutes happening right now is good. Like if it's
no, if it's a generation bump, we are not going to do anything. If it's a generation bump, we reconcile. Right?
yeah,
If you change anything in the desired state we should reconcile. I'm not for messing with that
Yes. Yeah,
promise
yeah.
of flux. The problem is nothing changes in the desired state, right? The controller restarts.
Okay. Well,
There is no
that's a little
generation
bit of a
block.
red herring anyway, right? Like sure, if there's a generation change, there's other ways to know. Like what I was saying is that like it, if an event comes in and your interval is low and the status shows that you were expecting to reconcile much further from now, but actually your last reconcile time was already past the interval, like you should reconcile. Like it's not really based off of the expected reconciliation time of whatever was put in there in status. It's whatever your last reconcile time is based off of your interval. And that information is already there.
Yes and
So,
no. It is not for all controllers. For example, source controller, due to the various discussions and things that happened some years ago, source controller does not do that.
mhm.
Um, Helm controller does not do it. No controller does
To
it, but customized controller because I didn't feel comfortable with this stuff. Only customized controller actually, even if there is no work to do and the dry run says no diff, I'm still updating the ready condition last transition time. While we had a huge discussion, many discussions about source control. I say like, no, but source control should never update TCD if there is no change in upstream, which I still don't agree with. I think if you went and you did something like half of the reconciliation in source control because you do a, let's say, a git remote ls, or you do a head request to the container registry to figure out what's the upstream version, you compare it to what's in storage, you did work. So
mhm.
you should update the last transition time. While Sunny and others will say, no, this is crazy. We shouldn't be touching etcd. We are not doing anything from a user perspective. So, and that causes now when, for example, building the Flux UI now is like very obvious. This is a very bad decision because you look at the UI and it says like, oh, the last time anything happened with this Git repo was 20 days ago. And people are saying like, what the hell? I'm having like a 1 minute interval. Why
Yeah.
nothing happened in the right? And the decision was no, we shouldn't update any timestamps if the end state doesn't change. While I think the ready condition should reflect the fact that has the controller did anything? If it did something, it should have a timestamp there to say, yes, I did my work. Yes, nothing happened. There is no drift or there is no new version in upstream, but I did my job. I actually acted at the interval when instructing me to do, because now there is like zero insight into this. The only thing that source controller does is issues a Kubernetes event, and Kubernetes events are deleted after 90 minutes. So if you are not there in those 90 minutes to look at the events, you have
Yeah.
no clue that source controller did his job or not, right?
And that actually breaks the countdown timer as well.
Of course, breaks
Yeah.
everything. Yeah.
Um, Something that would solve the concerns. I mean, like, of course you can flag the feature, but one way to actually make the feature tunable, to where somebody still gets the benefits of long reconciles being splayed out, but then shorter reconciles that happen frequently don't create a bunch of noise in etcd, would be to only write this field when intervals are over a certain value. Like intervals greater than an hour are the ones that, like have to have some sort of scheduling accuracy. But then intervals under an hour, it's like, oh, okay, if something comes in, we're just going to reconcile them all at once. But then you could, as the cluster owner, you can slide that. Like maybe it defaults to 5 minutes. But then the cluster owner can move it to like, actually, no, I don't want updates on timestamps for anything under a day. But if it's a day or a week or whatever, then I don't want those things. That's like my rate limit threshold. I don't know. It's a weird tuning
To
method.
update the status? No, man. I think we should always update the status if something happens.
Yeah.
If we consume compute, and we do, and network and IO, right? We go out, we do a remote ls forget. We then read our storage, we get that from the storage, we do checksums, we do so many things. And then people are saying, oh, I'm seeing source controller didn't do absolutely anything. I'm looking at the CPU, I'm looking at the network usage. Where are this stuff happening? Right? It's like not saying you are doing something when you actually do a bunch of things. I think it is the wrong way. And it wasn't so visible until I'm actually having this in a UI, and it's like extremely confusing. Uh, and it's also not something that Flux operator doesn't do that. Customized controller doesn't do that. All the controls that I've built doesn't do that. Like Source Watcher doesn't do that. If it touches something, it will say, I did this work with the result, no op. While
Mhm.
Source Controller does the same stuff, and Helm Controller does the same stuff, but they only issue Kubernetes events that get lost. And the
Yeah.
idea was, oh no, but anyone can look at the events. Well, no one is actually connected to the cluster all the time to look at these events. They are extremely ephemeral. In the last years, it proved that because Kubernetes is so noisy, no one actually stores these events anywhere, because you have like huge crazy costs in terms of storing all this data. So it's better to store it in the status. It's just a timestamp bump, like customized controller did that since forever and no one complained. It's a tiny patch
Yeah.
API call. It is way less heavier than issuing a whole event with a huge message, like what source control does. We could actually drop the event because those are very noisy and update the status, right? And it will be like uh, an
Mm,
improvement in many ways.
it yeah, it's not exactly the same to drop the events because the events are a history as well, but yeah, I mean effectively.
History for 90 minutes.
Yeah. I mean it's
Yeah.
like you would be able to see like, oh, I changed the interval and it was reconciling every 10 minutes and now it's actually reconciling every 1 minute or something. But I mean yeah, not exactly the same, but the utility is questionable.
Yeah.
Give people a way to turn them off if there isn't already a way to turn them off. So
Yeah, there isn't a way to turn off right now in Flux any events.
yeah,
They are also, all of them are sent to notification controller over the wire,
yeah.
over the CNI, and then notification controller says, I don't have an alert for this event, I'm going to ignore it. And it logs and it issues an event, right?
Mm,
So
it's a bit,
it's quite, there is a lot of noise
yeah.
um, in the eventing system. That's why also Kubernetes has no guarantees that events will actually make it in etcd. There are I've seen many situations where they actually get dropped before they get persisted.
Mm,
Um, because there is a priority queue there. Of course, Kubernetes should prioritize someone change a deployment spec and not, oh, I need to deal now with 1 million events sent by random controllers. Let's store all of that in etcd and don't do other things. Like events have the lowest priority in terms of, and there is no guarantee that they will be stored.
yes.
And that's another issue that when someone on Slack had an incident with some Kubernetes provider, I don't remember who. It wasn't one of the big three clouds, a
Mm,
smaller provider. And they had some issues with the scaling of the control plane. And that person was saying Flux is stuck. I'm looking at the Helm release, I see nothing. And Flux was not stuck. It was just that we don't update anything in the Helm release. We only issue events, and when the control plane is running into, it's at capacity, it will just drop events, right? So I
Yeah.
spent like 1 hour trying to debug that. Then uh,
That's really frustrating too because
the control plane recovered, and then we saw the events. It was like,
Flux, Flux is
yeah,
supposed to be
damn.
like the thing you trust in the control plane to to give you control. Like if you don't have access to the cluster, but you can get read only information out of it, and you make a change in Flux, you should be able to see that it's doing something as effectively as it would be like running kubectl in your terminal. Like you should know what's happening. And if the cluster is under duress because some workloads are battering the API server, which is very reasonable, Flux manages all kinds of add-ons that could be very badly behaved.
Yeah.
And that's like by design, right? Like Kubernetes is a computer, you should be able to run a for loop and do bad things if you want. But ideally, Flux should be considered part of like the kernel in a way, right? Like this is a really core piece of interfacing with the computer. So the status information coming out of it, like you should be able to know what's happening. And like when you run a for loop on the computer, it shouldn't be like, oh, now I can't see what Flux is doing. I agree.
Yeah, issuing only events and not saying that we did work when we did, it's
It's a good technical argument too that customized controller produces these kinds of updates, probably in a larger volume than almost all of the other Flux controllers. Maybe only Helm release is the only other one that people use in massive, significant quantities to where like doubling or 10xing the volume of these timestamp updates by implementing it across all Flux APIs is probably not going to significantly affect people's clusters at this point. But I guess we should measure what it is. Like what's the storage and ledger footprint of implementing timestamps every minute for all of the APIs. Um,
yeah, definitely, and we can definitely measure them
yeah,
because we
see if it's see what's the cost and like if we feel it's something that we need to flag. Um, because this, I can see why somebody on a Raspberry Pi would be worried about, like constantly updating a timestamp in etcd or something. But
they
because
get events anyway.
yeah, I mean, it's like even there probably are some APIs in Kubernetes that behave this way. I don't know. I mean, like the pod, if it's just sitting there running, doing its workload and everything is happy, then I don't think you really get many writes just because it's running.
Depends. Do you have readiness checks? Do you have liveness checks? Every time a check is considered okay, that's all right. You know when the you have in the audit log, you'll actually see when kubelet has run uh,
Yeah,
a readiness and liveness check. So
yeah.
Kubernetes actually does that. When it does something, even if the result is okay, nothing changed, it tells you like I did something.
Yeah, the readiness is status information that's crucial to be consumed with some level of SLA by things like ingress controllers and kubeproxy and stuff, right?
Yep.
The
And is equivalent to a Flux source, right? Because that's also critical when you
yeah,
want to know, did Flux even try to see if I have any change? Because it's another confusion here, like another thing that happens a bunch of times. People do a commit without a push.
It isn't a timestamp though, it's just a bit flip, right?
No, you see when kubelet called the endpoint and the result gets traced. You can see in the audit logs.
Yeah, but what gets appended to etcd though is just a generation bump of readiness, right? And then the endpoints controller is only watching changes to readiness.
Yeah.
And it's all gRPC, so it's literally bits, right? Where it's like we're talking about doing a generation bump of a timestamp string to status of a custom.
No, the generation will never bump you when you touch status.
Hmm.
That's how Kubernetes works. When
So
you touch status,
just a
generation of course doesn't.
status timestamp bump.
Yeah.
But yeah, we're
And custom resources are not versioned. So unlike pods and anything else in Kubernetes, there is no versioning.
yeah.
So you update in place. It's like you are not, it's the same as updating a counter or whatever.
It's bigger by a lot, but yes.
What do you mean? Why would
Like
it be bigger?
ready Boolean would be a bit flip, right? Or a byte. But yeah, the string container in JSON is going to be much larger size for a timestamp.
Oh, when you send a patch to the API, yeah, it's
Yeah, and then the consequence of it being appended to etcd ledger is going to be a lot larger than a bit flip.
if you have audit log enabled, because otherwise it does not get stored.
Mm.
Um, because it does not change the generation, as I said. So it's not it's treated differently. Unless you have audit log enabled when you want to know anything. So yes, they so of course it's there.
Mm.
Okay, we can talk another time about this. It's kind of late. We are 20 minutes
Yeah.
over, and I have a ton of stuff
That
to do.
was a very interesting conversation. I appreciate you guys let me listening in.
Yeah, no worries. The dev call.
Nice.
This is how we make
All
Flux
right.
good. So yeah,
Have a good
Goodbye.
coming
day
See
on.
you
still.
next week. Thank you.
See you then. All right. Goodbye, everyone.